video, we're going to look at the 2015 FRQ number 5. Let's take a look at it. So we got a nice graph. It's the graph of the derivative. It says the figure above shows the graph of f prime, the derivative of a twice differentiable function of f on the interval -3 to 4. The graph of f prime has horizontal tangents at x equals -1, 1, and 3. The areas of the regions bounded above the x-axis are 9 and 12 respectively. So the area under here is -9 and the area under here is -12. And then part A says to find the all x coordinates at which f has a relative max. So for part A, if we have a relative max, then that means that f prime of x equals 0 and that f prime of x changes from positive to negative. So there's only one place on this graph where that happens, which is right here at -2. So x equals -2 is a relative max since f prime of x changes from positive to negative. All right, part B. On what open intervals contained from -3 to 4 is the graph both concave down and decreasing? Give a reason for your answer. Okay, so in order to be decreasing, f prime of x has to be negative, and to be concave down, f double prime of x has to be negative, or f prime of x is decreasing. Okay, so let's go ahead and look at the graph and see where that happens. Well, f prime of x is less than 0, basically the whole graph, and it's decreasing from -2 to -1 and 1 to 3. So it's the pieces that overlap. So our answer is going to be f is concave down and decreasing from -2 to 1 and 1 to 3, since f prime of x is less than 0 and f prime of x is decreasing, or you can write since the second derivative is less than 0. Either way is fine. All right, part C, find the x coordinates of all points of inflection on the graph. Okay, so we have a point of inflection when the second derivative equals 0 or is undefined. But more importantly, so the first derivative needs to change from increasing to decreasing or decreasing to increasing. Okay, so let's go look at all those values. It actually tells us it in the problem. It says it has horizontal tangents at -1, 1, and 3. So let me just get rid of this. So at -1, 1, and 3. And that's pretty much going to be our answer. So x equals -1, 1, and 3 are inflection points since the second derivative equals 0 and the first derivative changes from increasing to decreasing or decreasing to increasing. Part D, given that f of 1 equals 3, write an expression for f of x that involves an integral. Then find f of 4 and f of -2. All right. So our goal here, we know that f of 1 is equal to 3. This is going to be one value of each integral. And then we want to find f of 4 and f of 3. So an integral that gives any value of f is going to be the integral from 1 to x f prime of t dt. And if I want to find f of 4, it's going to be the integral from 1 to 4 f prime of t dt, and that's going to equal f of 4 minus f of 1. So in order to find the integral from 1 to 4, it actually tells me in the problem that it's just 12. Right up back here, it says that from 1 to 4 it's 12, but keep in mind, because it's underneath the x-axis, it's going to be negative. So this is going to be -12 is equal to f of 4 minus 3. So I get f of 4 is equal to -9. And if I want to find f of -2, so I'm going to do the integral from 1 to -2 f prime of t dt, which is equal to f of -2 minus f of 1. So I need to flip this integral, and it becomes -2 to 1 f prime of t dt is equal to f of negative 2 minus f of 1. So it's negative, and the integral from negative 2 to 1 is 9, but because it's below the x-axis, it's going to be negative 9 is equal to f of negative 2 minus 3. So this is 9 is equal to f of negative 2 minus 3, so I get the answer is f of negative 2 is equal to 12.